Okay, welcome back guys to Gamdo YouTube channel. So today we're going to learn basic thing about landscape auto material. So as we know that making game we have to create landscape, but how can we create landscape which is flexible to our project game? So by using the auto material setup, we're going to make it more easier if you want to create another landscape for your project or for the other project. Okay, so let's begin. Okay, let's begin by creating folder. Right now I have in here landscape auto material. So we have function folder in here because we're going to create some function that we're going to use in our blueprint later. So I will share the file in the description below, but if you want to follow along with me how to create the auto material and learn about the auto material landscaping, so just bear with me until the end of this video. Okay, so let's get busy. Would like to know how to create the material function, it's easy. Just right click, go to your material right here and choose the material function in here. So as you can see, the description about the material function is a collection of material expression that can be reused in different material. So we're going to reuse again and again. That is the point about the auto material, because you only once create the auto material function and then you can apply it to many projects that you have. So let's go. So just material, go and then to material function. I will show you some of the material that I already created here. So I will open this one, and this function is the material function depth of fade. So what is depth of fade? So remember that we're going to create auto material. So we're going to put some material and then we want to make it into many layers. So because we're going to put it into many layers, we want some of the material will be fade away in certain distance. Okay, if you confused about what is distant blend flat line, what is distant blend flat offset, actually this one is like a scalar. So if you hover over your mouse in here, you have like a hint right there, like hold Ctrl and Alt, do the thing, hold Ctrl and Alt, you will see that right here, this is the scalar parameter expression. Output a single float value constant that can be accessed and changed in instant material on the fly by code or on the fly by code. So actually this one is only a scalar. Just hold your keyboard on S, okay, S, and then left click. There you go. So you have the scalar. So just name your scalar to the parameter name that you want. Okay, in my case I want to put it into distant blend fade line, so like that. So we just delete this one, and as you can see I have two right here. This is all the scalar, and I have a value right here 4096. You can put like your number. This one is my tweaking number. So the next thing we have here, so do the same thing again. Just click right here, Ctrl and Alt, and as you can see, this is only static boolean expression used to provide default value. By default, this one going to be true. Right here we have camera depth fade. So I don't create this one. This one is already inside the Unreal Engine, so just right click again to find that camera depth fade. As you can see, we have here camera depth fade. We want to combine the distant blend fade line, distant blend fade offset with our static boolean. So we need this one in order to blend it together. So just delete that one. Okay, so how can we combine, how can we connect between this node? Yeah, actually this one is the node. Yeah, everything that in here is all the node. So because this one is the blueprint, yeah, in Unity they use like a bolt, I think, and in Unreal we have like blueprint in here. Blueprint is like a visual scripting where we have node and we have to connect between node and node. So in order to connect with your node, you just use your left mouse, drag your node, and then once you off your finger from your left click, you will be asked to get or to give the node. So right here we want the camera depth of fade. Okay, but if you already have the node like this one and this one, for example, I will just delete my connection in here by clicking use Alt and clicking left click. Bam, there you go. So you just drag it. So we have this one, and then we connect with the mask. So mask is like, this is only like mask component. So you just component of mask right here. See, this one is only component of mask, and then if you can see we have RGB. So what we only want is we only want the R, so the red channel. Yeah, connect with the output. The output is the depth fade of mask right there. So we have one of our material function. Okay, so we just if you finish with your blueprint, don't forget to save it and then apply. Okay, apply, or you can apply and save it. Okay, let's go to the other material function. Right click again, go to the material, and then material function, and then name it to my material function opacity. Right click in here, and oh yeah, if you want to like pan your camera like this, use your right click in order to pan your camera. You can like zoom in, zoom out here with your mouse, middle mouse scrolling. Okay, this one is quite complicated, but if you confuse, just remember that this one on the left side is usually the constant or variable. Yep, constant or variable or parameter. So we have some of the value in here. Sorry, we have some value in here. Whoops, sorry. We have some value in here that we're going to determine whether this is solid or not. So we have like solid right here. We have solid opacity. So what is the solid opacity? You just hover over your mouse right here, static switch parameter. So this one is static switch parameter. This is like boolean value. As you can see, we have true and we have false. So this one going to be true for 1 and going to be false with the input opacity. Okay, so and then use a solid opacity, we're going to multiply, and the multiplier number is going to be the per instant fade amount. So this one is the per instant fade amount. So material expression per instant fade amount, this one is already inside the Unreal Engine. Okay, so we have the multiplier number, and then the multiplier number we're going to feed it to the use depth fade. So this one, the multiply number going to be the false condition for our use depth fade. So where is our true? So actually our true will be coming from this one. Our true will be coming from our camera. camera fade range and camera fade offset. We fit it, both of them, we fit it into camera depth fade. So we have the camera depth fade value of result, and then we just like inverse the value into minus. So once we have that value, we multiply in here, so this multiply will be for our deter temporal. So this one going to be for our alpha threshold, and the round number of camera depth fade going to be our alpha channel in here. So this one is lerp. So lerp is basically linear interpolation between two input. Yeah, this is similar to when we want to create the changing between one value to another value. Okay, so we have the interpolation, we have the one number, which is the alpha number in here, the A number, I'm sorry. So the A number coming from the solid number right here, and we lerp with the other number, which is the B number. The B number is coming from the multiply number of the inverse number of camera depth here, which is we fit it into the deter temporal AA. So this one is 1 and this one is minus 1. So we have final result in here, which is the output. We name it opacity. Okay, so that is the second function, material function we have. Okay, let's go as usual, just apply and then save it and then close it. Let's go to the third. So the third one is material function for pivot mask. Okay, so this is more simple, it's not quite complicated. So we have like absolute word position. Okay, so the absolute word position that we're going to use is the X, Y, and Z, because we want to because we play in 3D dimension. And then the absolute position of our material, and then we have the object pivot point, which is the pivot point, which is the orientation of our material. So where is the object pivot and where is the absolute work position of the object that use our material? Okay, so we fit it into this cell right here. So this is more easier to understand, I think. Yeah, we put it into this cell right here and we divide it with the 64. Okay, so what is 64? As you can see, this is the constant expression output. So you just tweaking this number. Okay, divide by 64 and we have the output pivot mass in here. So that's easy, right? So it is easier to understand. Okay, just save it and hit apply again, and then let's go to another material function again, which is the material function pixel depth deter. So right here in this material function, we have another deter temporal AAA, and as you can see, what is this one? So this one is material function expression, allow you to use external material function from another material or function. The external function input and output node become input and output of the function call node. If material function is selected in the content browser, when placing one of these expression, it will automatically be assigned. So actually, what is deter temporal AAA? As we know that this one is anti-aliasing. So temporal anti-aliasing or TAA. So this one, we want the Unreal to change the noise every time or every frame. So every frame, every movement that our character use, or every movement that the object changing position or from our camera angle, the noise will be changing as well. And then we have right here the pixel depth jitter. This one is only a scalar. Yeah, if you like Control and Alt, you see this is the scalar parameter. So 5 is the tweaking number, and then we multiply this one to A and B, and then we feed it into the lerp again. So we have the B in here, and then this one, and the A is coming from the value which is the 0. Yeah, we going to lerp. So we already learned right here, we want to lerp between the any number of this jitter anti-aliasing that you use, and then we multiply by 5, and the lerping will be start from 0 to any number that multiply by 5 in here. Bam, there you go. Okay, so and then the result will be, we forget. So we have the alpha, don't forget the alpha, and we have in here, this one is the another scalar parameter, and we have the pixel depth jitter, which is the number is 256. This is the tweaking number. So and then we feed it into the camera depth of field, and we put it into the alpha. Okay, so from this looping we feed it into the use pixel depth jitter. Okay, so this will be the true and 0 will be the false, and we feed it into the pixel depth of jitter. Let's close this one, because we have another material function in here, which is the roughness. So we go here, and as you can see, we have roughness function, material function in here. We have input roughness, which is the input material expression function input, and then we have -1, which is the like inversion of value. So we inverse this one to this one, and then we feed it into the use inverted roughness, and then if this is true, with this is going to be minus, if this is false, going to be the input number, and then we feed it into multiply, and then roughness, we have another scalar number in here. So the scalar will be 1 for the multiplier B. So we have minus and we have 1 right here, and then multiply, we're going to go to the power. So the base number will be the multiplication between minus and the 1 in here. Bam. And then the exponential in here, constant exponent, will be the roughness power, which is the scalar like 0.5. So this is the output roughness. There you go. So we done with this one. Don't forget to apply and save it, and close it again. Let's go to another material function, slope material. Okay, the slope material function in here. So in here we have the pixel normal. Okay, pixel normal, which is, as you can see right here, pixel normal WS is expression output vector that are representing the direction of the pixel are facing based on the current normal. Okay, and then right here we have the input, and the output going to be 2. We have 2 output in here. One is the slope mass, and the other one is output slope normal mass. Okay, so we want that our material will be adapting to any slope of our landscape. So that's why we have output slope mass, and we have slope normal mass. Okay, So for the output of slope mass right here, we have slope mass right here. So we put the normal pixel normal WS into our slope mass, and then we add with our slope mass another slope mass in here. But the difference, as you can see right here, this one is the tangent normal, and this one is the fall of power. So the fall of power is coming from the multiply number of input multiplied by 6 right here, okay, and the value parameter in here we have 2. This is the constant value, so we combine the tangent with the fall off and the chip constant. Okay, so after we have that number combined together, yeah, the tangent and the fall off and the chip constant, I mean, we climb it. So we climb it to minimum and maximum. As you can see, we have 0 and minimum, and maximum will be 1, and that's going to be the slope mass. The other output is the slope normal mass. So the normal mass is coming from the fall of power and the constant, and this one is coming from the input slope power, which is this one, input slope power. Oh yeah, don't forget, every time you create your material function in here, to expose to like library, because we're going to use it in our project. Okay, don't forget to save it, hit apply again, and let's go to another function we have here is material function for water mass. So the result is output is the water mass, and what we going to see in here, you can see that we have so many in here, quite complicated, but bear with me, because the easy way you can see is by seeing from the output first, and then we like reading it from the right to left. Okay, right to left. So as you can see, this is the output water mass is the result from the power. So from the power, base power, and the exponent constant is 4. So the base is coming from the multiplication of A and B, which is A is coming from a multiplication of slope mass, okay, slope mass, and the climb of many things in here. Okay, so actually what you see in here is all only the like operator. Yep. So, and this one is also the operator. Okay, so the way that you can understand the logic is by seeing what is the parameter that we use in here, or the function that we use in here. Remember that a function can consist another function, right? This function is like a big container. We can have like parameter, we can have like variable, and we can have like another function inside our function. So the way you understand this material function is by seeing what input, or what parameter, or what variable, and what another function we have inside this function. So as you can see, we have the output is coming from the power, and the power is coming from the multiplication between input, which is the snow vertex mass, and this one is the input snow that we're going to use later. And the other value is coming from the clamp of this logic. Yeah, we inverse the multiplication between what? Between the water word position, okay, and we multiply with the absolute word position and water max word position right here. So this one is the word position, by the way. So this one you just have to find it in here, word position, and you have that one. After that we have the water word position power in here. Once again, this one is the scalar parameter, okay, and we add it into here so we can multiply this one. Okay, down here we have the slope mass, and as you can see we only use the fall of power and constant, and we have like two parameter in here. One is the water slope parameter, the other one is the water edge contrast. Okay, so we feed the water slope power to the fall of power, and then the water edge contrast multiply by the input right there to the constant, and then so we multiply the slope mass, which is coming from water slope power and water edge contrast, with the clamp of the absolute word position and the water mass the water mass word position, okay, and water word position. So from the multiplication we multiply again the number of inverse from the input snow vertex that we have, and then after that we just power it by 4 to the output of our water mass. Okay, so that's it about the sum of the material or material function that we already create. Later in the next video we're going to continue creating another material function. See you in the next video. Bye for now. Have a great one.